Good afternoon. So we are going to start our week 6 session. Banana Sindhu, am I audible? Hello. Banana Sindhu, please unmute yourself. Good afternoon. So this is week 6 sensor and actuator problem solving session. Here we will discuss about some question, and if you have any doubt you can directly ask me. So Banana Sindhu, am I audible? Please unmute yourself. Okay, we can wait for 2-3 minutes, then we will start our session. Banana Sindhu, am I audible? Please unmute yourself. So this is about me. I am ARPITA BISWAS, a student of PhD in Electrical Engineering Department from Indian Institute of Technology, Jodhpur. And this is my educational background, that I did my MTech from IIIT Jabalpur in Micro Nano Electronics, and I did my BTech from West Bengal University of Technology in Electronics and Communication Engineering. And this is more details about me. You can directly search this link. And my class session is every Tuesday 7 to 9 p.m. So here we are going to discuss some question and answer, and if you have any doubt then you can directly ask me, and you can directly unmute yourself and you can give the answer. So we are starting our session. This is our question 1. Then the photolithography is and the first question is, the photolithography is an important step in microfabrication. What do you understand by the lithography? So first option is transforming pattern on a mask, and the second option is the transferring pattern on a substrate, and the third option is slicing wafer by laser or by UV, or the fourth option is deposition of any material on a substrate. Banala Sindhu, please unmute yourself and try to give the answer. Then I will discuss what is the right answer and why. At least try na. Hello. Banala Sindhu, please unmute yourself. Am I audible?
Fourth option, ma'am. I think.
Fourth option. Hello. Please unmute and try to give the answer. Then I will explain.
Ma'am, I think fourth option.
Deposition of any material on a substrate. No, this is not the right answer. See, what is the meaning of lithography? When we want to patterning from mask, when you want to pattern any structure on the device now, in that time we need the lithography. And what is happening in lithography? See, whatever you tell, deposition of any material on the substrate. Okay, for lithography stage, at first we have to deposit some material on the substrate, then we transfer the pattern of mask to that substrate or that deposited material. Okay, so it is not the part of it is the previous stage of the lithography. So here, what is the question? What do you understand by the lithography? Lithography is a pattern transferring process. So whenever you want to transfer any structure or any structure, like if you want to pattern any ID pattern, interdigited electrode on the substrate or on the deposited sample, in that time also we have used the lithography. Or if we want to pattern any micro heater, in that time also we need this lithography system, lithography process. So what is happening, at first we deposited some material, then on this deposited material we pattern whatever structure we want this. Okay, so then we go for the lithography system. So what is the lithography system? It is a pattern transferring system. So where the pattern is transferred, it is transferred onto the substrate, but is the material is deposited there na. There the pattern is transforming, so by UV exposure. Hema, so we have started our session. This is our first question, and please unmute yourself and try to give the answer. So this is our first question, that photolithography is an important step in microfabrication. What do you understand by the lithography? And the first option is transferring pattern on a mask. Second option is transferring pattern onto a substrate. The third option is slicing wafer by laser or by UV. Or the fourth option is deposition of any material on the substrate. Okay, she is leaving. So the right option is second option. Banana Sindhu, you got the answer?
Yes, ma'am.
So lithography is a pattern transferring process, and where the pattern is transferred onto the substrate or whatever material we have deposited now, from the mask to that deposited material the pattern is transferring. Okay, so deposition of any material, yes, whenever we go for the MEMS fabrication now, at first the first stage is there is three main stages like deposition, then patterning, and then etching. Like in these three main part of the MEMS fabrication we are going to follow whenever we want to fabricate any MEMS devices. So this is the previous stage where we have done some deposition of the material. Then on the deposited material we want to transfer any structure, like if you want to deposit a ID pattern or micro heater, so then we followed this lithography, and by this lithography process whatever pattern we want to transfer, this pattern is transferring from the mask to the deposited material. And then what we have done after the photolithography, whenever the pattern is transferred, then we go for the etching process. Whatever pattern we want we keep, and the other material we etched out. Okay, so here the right option is transferring pattern one to a substrate, option B. This is the second question. What is the flow of the modeling in COMSOL? So do you know about COMSOL? Please unmute yourself. What is COMSOL? Sindhu? What is COMSOL?
Ma'am, no idea, ma'am.
Okay, actually COMSOL is a software where we did the simulation of the devices. Okay, like there are other simulation software also present like Silvaco, TCAD, and for analog circuit we have used the Cadence software. So in COMSOL software we can also modeling or simulation of the fabricated devices can be done. So here like fabrication we at first deposited material, then we patterned, then we etched out. So in that way this is the fabrication process, but we can also simulate the data. And why we simulation, why we need the simulation process? Actual the theoretical we have if we want to match the theoretical data with the practical the fabricated device, in that case also the simulation is needful. So in that case we use this COMSOL software where we simulation where we modeling some of the devices, and this is the process. So here we are discussing which process, the process flow of this COMSOL. At first whatever done in COMSOL software whenever we go for the simulation process. So here some of the processes is discussed, like the first here actually we want the right flow like the step of the modeling in COMSOL. So we can rearrange like the first here it is mentioned that make the geometry, and option B is the post process, and option C is the add material, and option D is choose type of the study, and option E is apply physics condition. So what is the right flow of the process whenever we go for the simulation in COMSOL? So here the first option is A, C, then E, D, B. A means at first make the geometry. Make the geometry means you have to at first when you go for the simulation now. Then what we need, at first we need the structure. Then we have to draw the structure, and there is the some process is present. So the option, then the what is the process flowing? The first option after A is C. It means after making the geometry we have to add the material, and the next option is A, C, then E. Then after adding material, we go for apply physics conditions, and then option D means choose type of study, and then option B the post process. It means whenever the devices is done, then the post process is on whatever, and measure the output of the devices, like that. And the second option is CAEDB. C means at first add the material, then make the geometry, then apply physics condition, then D choose type of the study, and then B post processes. And the third option is ACDEB. First make the geometry, then go for the add material, then choose the type of study, then E apply physics condition, then B post processes. And the last option is ACEBD. A is at first make the geometry, then C add material, then E is apply physics condition, then B post processes, then D choose the type of study. So what is the right process flow? So try to guess the answer. Banala Sindhu, please try to guess the answer.
Ma'am, option A, ma'am.
Okay. Can you explain why option A?
First, we make the geometry, ma'am,
Okay.
and then add material, ma'am.
Okay.
Next, I don't know, ma'am. First two steps are I know.
Yes. Then after that, apply the physics condition. Then we go for choose the type of study, what type of study we want to do. Then next process is post process. So right option is option A. Okay, good. So this is the question number 3. Regarding COMSOL multiphysics video, evaluate the following statement. We should always model full 3D system. So it is true or false. It means here it is saying that only 3D system we can model, or we can simulate in COMSOL software. So it is true or false. Try to guess the answer.
Ma'am, true, ma'am.
No, actually this is false, because whenever we go for any software for simulation purpose, in that case we can also model 1D, one dimensional device, 2-dimensional, and also as well as the 3-dimensional system. Okay, so the right answer is false. So have you got the answer?
Yes, ma'am.
Okay. So this is question number 4. Only predefined multiphysics can be used in COMSOL multiphysics. Regarding COMSOL multiphysics video, evaluate the following statement. So the option is true or false. So here they are saying that only predefined multiphysics can be used. So it is right, or this statement is right or wrong? Only predefined multiphysics, because we have to need to add some physics there, multiphysics there, whenever we go for the simulation process in COMSOL. So in that case only the predefined multiphysics can be used, or something else also used. try to give the answer. At first go through the question carefully, then try to guess the answer.
And true, ma'am.
No, the answer is false, because manual multiphysics can be also used for in the console software. So predefined multiphysics also can be used, and as well as the manual. You can manually add the multiphysics whenever you want to simulate the devices in console. Okay, so the option is false. So next question is, to model thermal actuator, which physics will you solve for? The electrical and structural physics, second structural and thermal physics, and the third option is electrical, thermal and structural physics. Take your time and then give the answer. To model thermal actuator, which physics you will solve for? Electrical and structural physics, structural and thermal physics, electrical, thermal and structural physics.
Structural and thermal physics, ma'am.
Structural and thermal, and also the electrical physics. So right option is option 3, electrical, thermal and structural physics. Okay. And the next question is, why additional signal conditioning circuit is needed in between the temperature sensor and ADC, analog to digital converter? So the first option is, signal conditioning circuit will improve the sensitivity of an op-amp. The second option is, signal conditioning circuit will improve the power consumption. The third option is, signal conditioning circuit will improve the resolution, each level height. And the third option is, signal conditioning circuit will reduce the hardware. So at first go through the question carefully and take your time and try to give the answer. And there is no and don't think that you are giving wrong answer or something, right? At least you try, then I will explain. Why additional signal conditioning circuit is needed in between the temperature sensor and ADC?
And third option, ma'am.
Yes, the right option is third option. Can you explain? How to calculate the resolution? Okay, we will discuss later. So moving towards the next question. Calculate the resolution 8-bit to ADC with reference voltage 12 volt. So the first option is 46.875 millivolt. The second option is 39 millivolt, and third option is 1.5 millivolt, and the last option is 93.75 millivolt. So what is the right answer, and how to calculate the resolution if bit is given and also the reference voltage is given? Take your time and try to solve it.
First option, ma'am.
How you calculate?
Ma'am, 12 by 2 power of 8, ma'am.
Yes, the right option is first option, 46.875 millivolt. Good. And the next question is, why primer is coated before the photoresist? So the first option is primer coating remove the moisture. The second option is primer coating will clean the wafer. And the third option is primer coating improve the adhesion of photoresist with substrate. And the last option is primer coating will improve the alignment of the mask. So what is the right answer? There is no hurry, you take your time and then try to guess the answer.
First option, ma'am.
No, actually, how we remove the moisture, for removing the moisture, now we can bake directly. We can bake the substrate. Then the moisture will go out from the substrate or the device. So the coating is not the reason to remove the moisture. So it is also a hint that if you want to remove any moisture or any water molecule, then you simply hit, or we bake, or soft baking something, the hard baking also present. In that case also the moisture can gone. So it is not the right answer. So please try to, you take your time, then you can give. You think how each and every point here. At first, the first option is not the right answer. Then the second, but then you think about the second option. The primer coating will clean the wafer. Is it possible to clean the wafer, the primer coating? Because if you want to clean, there are some process like Piranoha, RCA1, RCA2 cleaning process. Then if we want to remove also, the IPA also used, the acetone is used. So some this type of chemical is used to clean the wafer. But if you coated it with something or other material or something primer, then it will clean, or something else also added on the substrate. So it is not the cleaning process, right? So second option is also is not the right answer. So what about the third and fourth option? Primer coating improve the adhesion of photoresist with the substrate. So whenever we want to go for the photolithography process, in that case we need to coated the wafer with photoresist. And what happened? Sometimes the adhesion of the photoresist is not good. So what do we want? We want to add or coated some other material on the wafer, and then we added the coated with the photoresist. Then we go for the photolithography process. And what about the fourth option? Primer coating will improve the alignment. The primer coating will improve the alignment of the mask. So at first we have to know what is alignment. Venkata Josika, this is our 8th number question. So why primer is coated before the photoresist? The first option is primer coating remove the moisture. The second option is primer coating will clean the wafer. The third option is primer coating improve the adhesion of the photoresist with substrate. And the fourth option is primer coating will improve the alignment of the mask. So please unmute yourself and take your time and try to give the answer. Venkata Joshika, please unmute yourself. At least try. Take your time and try. Then I will explain. Why primer is coated before the photoresist? Now I am explaining each point that primer coating remove the moisture. So whenever we hello.
Third option.
Yes, the right option is the third option. Primer coating improve the adhesion of the photoresist. And what about here the alignment of the mask? Actually, whenever we want go for the photolithography process, then after if we want to go for the for etching or some patterning process, there we have to align, like where we have to pattern in the same position we want to exposed UV expose we have to do. That's why the alignment is needed. That in that the alignment, if it is done, then the UV expose is we go for the UV expose and the the total photolithography process. So the here primer coating is used to improve the adhesion of the photoresist with the substrate. So right option is option C. Then the question number 9. Baking is one important step for photolithography process. Hard bake and soft bake are performed at, the first option is hard bake and soft bake temperature is 90 degrees centigrade and 120 degrees centigrade. The second option is 100 degrees centigrade and 120 degrees centigrade. And the third option is 120 degrees centigrade and 90 degrees centigrade. And the fourth option is 120 degrees centigrade and 120 degrees centigrade. So what is the right answer?
Third option.
Yes, the third option is the right option. And what about the time of the soft bake and hard bake?
1 minute, ma'am.
Yes. Venkata Joshika, what is the right answer? Please unmute yourself. At least try na. If you have any doubt, then you can discuss.
Clear, ma'am.
What is the right answer?
Third option.
Oh, okay. And do you know about the time?
I think 1 minute, ma'am.
And what about AC weight? AC weight is a negative or positive photoresist?
Negative, ma'am.
Yes, negative photoresist. So, what is the time required for AC weight for hard bake or soft bake process?
1 minute, ma'am.
No, it is not 1 minute. Actually, it is depends on the thickness of AC weight. Okay.
Okay, yes, ma'am.
So next question is HEPA filter stands for air filter. So frequently found in clean room. Which is the correct full form of the HEPA? High efficiency particulate air, high energy particulate air, high efficiency potential air, high energy pollution free air. Take your time and try to give the answer.
First option, ma'am.
Yes, the right option is high efficiency particulate air. Example of the primer. So we have previously discussed that why we need the primer, because if we want to increase the adhesion of the photoresist, in that case we at first coated the sample with the primer, then we deposited or coated with the photoresist, like positive or negative photoresist. So here the example, the question is the example of a primer is, first option is the HMDS, hexamethyl disalinase, S1818, SU8 and TIMA. So what is the right answer?
First option, ma'am.
Okay, and S1818?
No, ma'am.
What is S1818? Do you have any idea?
No, ma'am.
Actually, this is positive photoresist. And SU8?
Negative.
And what about TIMA?
No, I don't know, ma'am.
Your TIMA is a solution where we have done the wet etching process. Okay, whenever we want to etch the silicon, in that case, and if you want the anisotropic wet, if we go for the anisotropic wet etching process, in that case we use the TIMA, like that shape, this type of shape. Anisotropic means that type of shape. Okay, in a particular direction it etch out. So TIMA is a wet chemical etching process. Actually, this is a solution where we dip our wafer and it anisotropically etch our silicon. this is the question 12. Thermal actuator works on the principle of converting dash into dash. This leads to thermal expansion and hence actuations. The first option is Joule losses, thermal variation. So the what is the right answer? Thermal actuator work on the principle of converting the Joule losses into the thermal variation, or the thermal actuator work on a principle of converting the thermal losses into the Joule variation. And the third option is the thermal actuator works on the principle of converting the mechanical losses into the Joule variation. And the fourth option is thermal actuator works on the principle of converting the thermal losses into the mechanical variation. And this leads to thermal expansion and hence the actuations. I'm coming back in 1 minute. So you think about the answer, then we will discuss.
Second option, ma'am.
So try to give the answer. So this is our question number 12. The thermal actuator works on the principle of converting dash into dash. This leads to thermal expansion and hence actuation. So first option is Joule losses into the thermal variation. Second option is the thermal losses into the Joule variation. And the third option is the mechanical losses into the Joule variation. And the fourth option is thermal losses into the mechanical variation. No, not option 4.
Ma'am, second option, ma'am.
No, not the second option. Can you explain why thermal losses into Joule variation? Actually, the right option is the first option. In thermal actuator, works on the principle of converting joule losses into the thermal variation, and this thermal variation leads to the thermal expansion and hence the actuation. Preetham, you joined late, so do you want to discuss the previous 11 question? Then we can.
Okay. Okay, it's fine. I will see the video.
Okay. So this is the question number 13. So a HEPA filter used for HEPA filter trap the small harmful particles such as pollen, paint, dander, smoke and dust mites by forcing air through a fine mesh, or the HEPA filter trap gaseous contaminants from an airstream by absorbing the contaminants. So what is the right answer? At first tell me what is the full form of HEPA filter. And you have seen in the lecture video also the HEPA, multiple HEPA filter they have used. Take your time and try to get the answer. Why HEPA filter is used and what is the full form of the HEPA filter. Okay. Any other? Banala Sindhu. What is the right option? Venkata Josika. Previously we have explained now what is the full form of HEPA filter. Preetham, what is the full form of HEPA filter? Can you repeat? Please unmute yourself. No, actually the right option is the first option. For gaseous contaminants, now.
You are muted.
So the first option is the right option. By the HEPA filter, the high efficiency particulate air, the full form of the HEPA, and HEPA filter trap the small harmful particles from the and dust mites by forcing air through a fine mesh. But HEPA filter does not trap the gaseous contaminants. Okay. For trap the gaseous contaminant, there are different type of filter is used, and we will discuss this later. So the right option is first one. So here the different the another type of filter which is Hager filter, and it is also for the air filter, and here the full form of the Hager is, the first option is high efficiency gas air, the second option is high energy gas air, and the third option is high energy gaseous adsorber, or the last option is high efficiency gas adsorber. So what is the right option? Okay. Banala Sindhu, what is the right option? Take your time and try to give the answer.
Ma'am, I think first option.
No, it is not the first option. Actually, the right option is the option 4, high energy, high efficiency gas adsorber. Here we discussed now for trap the gaseous contaminants from an air stream by absorbing the contaminants. So this is the work of the Hager filter. So it's for in Hager filter, what it does, it traps the gaseous contaminants from an air stream, and it absorbs this contaminants. So the next question is mask plane having transparent. Actually this question is based on the lithography process, and this is again we are repeating, and we also discussed this question in previous session also. So this is the easiest question, that mask plate having transparent feature, and multiple times I have discussed it, so I think you will give the answer. Transparent feature and dark background. So the mask is dark field mask, bright field, or gray field mask, or black and white mask. Banala Sindhu, what is the right answer?
Yeah, ma'am. First option.
Yes, dark background, it means the dark field mask, and this is the opposite of that question, the mask having dark feature and transparent background. So what type of mask it is?
Dark film mask.
Bright field mask. So this is the photolithography process. So as I discussed, photolithography is a pattern transferring process. So here we have some point of the photolithography process is discussed. So what is the process flow? I think this question I repeat in my previous lecture also. Just have to recap this, the photolithography process, we are discussing this question. Okay, so what is the photolithography process flow? The first option is 2154673, second 1527643, and the third 1234567, and the last is 5124736. So at first go through the question that and each point, like spin coat photoregist, then what is the second option is the mask loading and exposure, then stripping the photoregist, then etching, soft bake, hard bake, and developing. So
Second option, ma'am.
okay, can you explain why second option?
First, we have to spin coat the photoresist, ma'am, and then soft bake, ma'am.
Okay,
And then we have to mask bright field mask or dark field mask, and then expose to UV light, and strip photoresist, etching. We make hard bake, and then etching, developing, and so on.
okay. So the right option is option B. And the second question, the question number 18 is, which statement holds the true for a biosafety cabinet? So the first option is the purpose of germicidal UV lamp in class 2 biological safety cabinet is to keep the interior clean when not in use. And the second is UV light not only kill the microorganism in the biosafety cabinet, but it also destroy living cell in your body. In particular, it can cause painful damage to both your skin and your eyes even after its intensity drops below the effective level. So the first option is only A, the second option is only B, third option is both A and B, and the last option is neither A or not B. So which option is true? Go through the question carefully and try to give the answer. Okay. Banana Sindhu.
Both A and B, ma'am.
Can you explain?
Ma'am, UV light will damage us, ma'am, our skin when we expose,
Okay.
and it is used for cleaning purpose of our devices, ma'am.
Okay. So the right option is option C. So the next question is why hard bake is required. The first option is reduce the solvent content in order to stabilize a resist film. The second option is make more resistant to wet chemical etching. Third option is reduce the undercut of the resist during the wet chemical etching, and the last option is both option B and C. Okay. Banana Sindhu, please go through the question carefully and try to give the answer.
Ma'am, third option, ma'am.
Reduce the undercut of the resist during the wet chemical etching. Yes, it is true, but the option B also right. Make more resistant to wet chemical etching. Okay, so that's why we go for the hard bake, then we go for a wet chemical etching. Because if we don't require this process now, in that time, if we go for the wet chemical etching, so photoresist also gone. So that's why we go for the hard bake process.
Ma'am, what is the meaning of reduce the undercut of the resistance?
Reduce the undercut of the resist during the wet chemical etching. So if this type of shape is coming now, so undercut means that type of shape, like in that portion. So next question is why soft bake is required. First is reduce the same option is here, reduce the solvent content in order to stabilize the resist film, make more resistant to wet chemical etching, reduce the undercut of the resist during the wet chemical etching, and none of the above. So why we go for the soft bake process? is the right option, Banana Sindhu?
None of the above, ma'am.
No. Go through the question carefully.
Maybe first option, ma'am.
Yes, the first option is the right answer. Because make more resistant to wet chemical aging now, for that case we want hard bake. Also reduce the undercut of the resist during the wet chemical aging. It is also required for the in that case also we require the hard bake. But in initial stage now, to reduce the solvent content in order to stabilize the resist film, we go for the soft bake process. So here the line, the sentence is sensitivity of temperature sensor is 10 millivolt per degree centigrade. It refers to, so what is the meaning of sensitivity of any of temperature sensor is 10 millivolt per degree centigrade?
We have to comment on that.
Yes.
Its meaning is for every 1 degree centigrade, the temperature sensor is giving the increment in the voltage by 10 millivolt.
Yes. And the second question is, if we want to interface temperature sensor to ADC, which interface we will use?
Which interface?
Yes.
Which device we are using?
Yes.
So the Arduino board.
Okay, but there is a specific device is used for accuracy or get the higher resolution. Okay, where the temperature sensor to ADC we have to connect.
To the signal processing, that is the OPM amplifier.
Yes, the signal conditioning. And we design a signal conditioning circuit by using, what is the right answer, diode, op-amp, multiplexer or ADC? Okay, Banala Sindhu, what is the right answer? And also, have you understand the previous question? Banala Sindhu?
ADC, ma'am.
No. The right option is the op-amp. Okay. At first, if we want to, here you see, if we want to interface temperature sensor to ADC, in that case we need signal conditioning. So signal conditioning, it's increases the accuracy of the output, or it also increases the resolution. That's why sensor temperature is connected with the signal conditioning and then signal conditioning to ADC. Okay, so now the question is, we design this signal, so how this signal conditioning, so in between the temperature sensor and the ADC we need the signal conditioning, and now the question is how we design the signal conditioning circuit. So by using the op-amp we design a signal conditioning circuit. Have you got the answer? Now it is clear?
Yes, ma'am.
Okay. So this is also the basic question of MEMS fabrication process. So main three process in MEMS fabrications are, we already discussed.
Three processes means the fabrication steps.
Actually, there are three main fabrication process. Like there are so many types of fabrication process, na? Like photolithography, etching, or
Yes,
deposition. Okay. So, what is the main three fabrication process?
the lithography and the deposition.
Lithography, deposition, and
Ma'am, deposition, patterning, etching, ma'am.
yes, the right option is deposition, patterning, and etching is the main three process of mains fabrication.
Okay.
And the next question is, which is not a MEMS fabrication process? First option is wafer cleaning, second option is deposition, patterning, then etching.
Cleaning.
Why cleaning?
You
Wafer
already
cleaning,
said that there are three main steps: the deposition, patterning, and etching.
Okay, three main stage, but why wafer cleaning is not the MEMS fabrication process?
It should be there, but I don't know.
No, actually
ma'am.
this is
It
the
is pure, I think.
what? Banaras Sindhu?
Ma'am, it
The
is
MEMS
already
devices
pure.
are fabricated on the glass substrate.
MEMS devices fabric on the glass substrate. So you can use the silicon, na? Also you can use the glass.
Okay.
Like if you want to design a chemi-resistive, just
Yeah, ID patterns on wafers. So we need to clean also.
yes. Actually, this is the additional process. At first, we need to clean the wafer, but main fabrication process is na. This is the main fabrication. This wafer cleaning is the additional process. So first we clean the wafer, then we go for the fabrication. Okay.
So we can say the cleaning process is the pre-fabrication process.
Sorry, can you repeat?
Its meaning means the wafer cleaning process is the pre-process of MEMS
Fabrication.
fabrication.
Okay. Yes. Here we can discuss about the cleaning process. Do you have idea what type of cleaning process is used?
RC cleaning.
Yes, RCA and another.
The process that we use in lab generally not RC. That is the simple process with the three steps, na, that where we use acetone, IP, and the Pirano solutions.
Okay. And what is present in the Pirano solution? How you prepare the Pirano solution?
Pirana solution, I think, is the ratio of the two chemicals, three in the ratio of 3:1. The hydrogen peroxide and just H2SO4.
Okay. And what about the RC1 and RC2?
That's not remember.
Okay. For organic and inorganic particles removal, now we follow this process RCA1 and RCA2. Like 5:1 or 6:5:1 something is ratio. H2O2 is also added, and some H2 or H2O2, and also some HCl solution is present in RCA2 solution, which remove the inorganic compound, and in organic compound RCA1 is used. I think NH4OH is used. NH4OH and DI water, and also H2O2.
Okay.
Next coming, how many types of optical lithography are there? 1, 2, 3 or 4?
Two.
Any other answer? Balara Sindhu? Have you heard about the printing lithography something? And
No, ma'am.
if answer is 2, then what type of optical lithography are present?
Ma'am, maskless and with mask. Maskless where we use the laser printer.
Okay, actually I am here asking about the printing lithography process.
Okay. That they use the what we call the molding type of thing, the PDMS things.
No, have you heard about the contact printing?
Yet, but not right now. Don't know about. We have to make some mold kind of thing and then print that same pattern on the something.
No. Actually, there are 3 types of printing lithography process in optical lithography, like contact printing, proximity printing, and projection printing. Okay.
Projection printing.
Have you heard about it?
Yes.
Okay, so I'm asking about it. So there are 3 type of optical lithography, printing lithography are present: contact and projection and proximity.
Projection.
So now coming to the question, what is the difference between the contact and proximity optical lithography technique?
Yes.
What is the difference?
Where we use that mask and wafer in the contact, that is contact printing, and where we use the mask and that wafer apart from some distance, that is proximity printing.
So what is the difference between proximity and projection?
Proximity is the already developed, but in projection I think we use the lenses also from some distance to magnify or resolution.
Yes. And the disadvantage of the contact lithography?
That a mask is not we can't use the mask for many times. That is the image by contact printing.
Yes. Banana Sindhu, have you got the answer? Or if you have any doubt, then we can discuss. Banana Sindhu?
No, ma'am.
So this is clear to you?
Yes, ma'am.
Okay. So this is the next question. What is the difference between the contact and projection printing? Banana Sindhu? What is the right answer? Banana Sindhu?
Don't know, ma'am.
Preetham?
Yeah, already told me contact में तो we use the mask and that wafer in contact. But
Okay.
in projection we use separately from some distance.
Here you can see this is the light source, then the optical system, then the mask is present, and this is the photoresist, then below the photoresist is the silicon wafer, and this is first one is the contact printing. So what is happening in the contact printing? So the silicon wafer, then photoresist, then mask. So there are directly contact with the mask and the in between the mask and photoresist, now this is directly their contact is present. So that's why it is called the contact printing. And this, what happened in the second figure, this is the light source optical system, then this is the mask, but in between the mask and the photoresist there are a small difference, or there are some gap present in between the mask and the photoresist. So what happened when there are contact between this mask and the photoresist? So if we go for the multiple time, if we go for use this type of contact printing, so there is a possibility to that our device can be affected, or there is some defects is present. Okay, that's why if we take some gap between the mask and the photoresist, so this type of defects can be removed, or this type of effects can be less. That's why there is a small gap between the photoresist and the mask. So this type of printing is called proximity printing. But what happened in the projection printing? So at first see, there is the light source, then the optical system, then the mask is present. So upper portion the mask is present. So when the light is coming from the mask, in between the photoresist and the mask there is a lens is present. Okay, so this is the main difference between the proximity and the projection. So there in proximity also, the in between the mask and the photoresist there is a gap, but the gap is very small. But what is happening in the projection printing, in the difference, there is a gap between the mask and the photoresist, but in between also we have used the lens, so it is also increases the resolution. Also we can reduce we can use it for the smaller devices, okay, for the smaller structure. That's why we go for the projection printing. So this is the first, the contact printing, second one the proximity, and third one the projection. So why we go for the proximity printing? Because if we go for the contact printing, there is a possibility that our that the defects is present in our device, because if you use the multiple time, then there is a possibility that our the defects in our device. That's why if we increase the increase the gap between the mask and the photoresist, then this problem can be resolved. That's why we go for the proximity. But if we want to go for the better resolution and for the smaller device structure, in that case we use the projection printing. And what is happening in the projection printing? In between the optic mask and the photoresist, we have used a lens. Have you got? Banala Sindhu, this is clear, or any doubt?
Yes, ma'am.
Meghna?
So in projection printing we use the lens just for the remove the diffraction problems.
Yes, it can reduce the defects, and also for the resolution you can get better na, and also a smaller size.
Smaller size of the beam.
Yes. Meghna? Banala Sindhu, what you understand from the figure? Can you explain? Banala Sindhu? Actually, I want to know, this is clear to you or not. So please, if it is not clear, then please tell na. Banala Sindhu. Meghna, please unmute yourself. You can write, your voice is not clear.
Clear.
Can you explain from this figure what is happening here? Banala Sindhu. So this is the last question, then a step in lithography process. So it is already discussed in our previous session also, but for the recap, that's why I am explaining this question. So Meghna or Banala Sindhu, can you explain all of the lithography process? Banala Sindhu, at least try na. Pritam, can you explain? Then we will go for the previous 11 question. Actually, we have covered all of the question.
Okay. So after the cleaning of the wafer, we have to first is this spin coat
Okay.
of the photoresist using this spin coat.
And yeah, before the spin coat, what we have done?
That for moisture removing, we have to put for 1 minute on the hot plate.
No, for increasing the adhesion of the photoresist.
Before spin coat, na,
Yes.
we have to first dry the wafer after cleaning by using nitrogen.
Okay, but for addition of the photoresist, na, another process is done.
Before spin coat, what is
Increase the addition of the photoresist.
not
Okay, then after the photoresist.
after the spin coat of photoresist, we have to use a soft bake on hot plate for according to the photoresist like 1 minute for 90 degree 100 degree centigrade. Then after loading the mask and exposure according to the dose of the light source for the particular photoresist, and developing the solution, develop a solution for developing the photoresist, and then hard bake and removing the photoresist using the sheet.
Okay. And what is the main difference between the photolithography process in for AC weight and for positive photoresist?
Yeah, I little bit remember that the temperature difference between using during the soft bake and hard bake. The temperature I think that is 65 degrees centigrade.
Yes. And after the soft bake, then we go for the hard bake process for AC
Yes,
weight.
yes. After initiate, yeah.
Yes.
After soft bake, directly in the hard bake.
So next we are going to discuss our previous 11 question. So this is a simple question that photolithography is an important step in microfabrication. What do you understand by the lithography? First is transferring pattern on a mask. Second, transferring pattern one is substrate. Third is slicing wafer by laser or by UV or deposition of any material one is substrate.
B option.
Okay. And this is the question 2. What is the flow of the modeling in COMSOL? First is make geometry, second is post process, third is add material, and D is choose type of study, and E is apply physics condition. And these are the option. So what is the right option?
Option D.
Why option B? Go through the
D.
option carefully.
You have to make, then first make geometry, then add material, then
Okay, then
apply the physical.
apply the physical condition. Then
Then yes, okay. Okay, then choose the type of study. The option A, I think.
yes, option A is the right option. This is the question 3. So regarding COMSOL multiphysics video, evaluate the following statement. We should always model full 3D system. So it is true or false?
I guess true.
What is the right answer?
Maybe true.
No, it is false because we can also model full 2D and one dimensional devices. Okay. So not only 3D system, it is also useful for 2D and one dimensional.
But question is, we should always.
No, it is not always a model.
Okay.
Okay. This is the question number 4. Only predefined multiphysics can be used in COMSOL multiphysics. Regarding COMSOL multiphysics video, evaluate the following statement. True or false? Only predefined multiphysics can be used in COMSOL multiphysics.
It's false. I think we can also define
Yes.
model.
Manually also we can define the multiphysics. So the question number 5 is to model thermal actuator, which physics will you solve for? Electrical and structural physics, structural and thermal physics, or electrical, thermal, or structural physics? So you think I'm coming back in 1 minute? So what is the right answer? Preetham?
I think 4.
Uh, Option?
4.
Yes, the electrical, thermal and structural physics.
Yes.
Next, why additional signal conditioning circuit is needed in between the temperature sensor and ADC? First option is signal conditioning circuit will improve the sensitivity of op-amp, and the second option is signal conditioning circuit will improve the power consumption. Third option is signal conditioning circuit will improve the resolution, each level height, and the fourth option is signal conditioning circuit will reduce the hardware. So what is the right answer?
C option.
Yes, the right option is C. The next question is calculate the resolution 8-bit of ADC with reference voltage 12. The first option is 46.875 millivolt. Second option is 39 millivolt. Third option is 1.5 millivolt, and the fourth option is 93.75 millivolt. So please calculate it.
Option A, ma'am.
So what is the calculation? How we calculate it?
The reference voltage divided by the 3 d power the bits minus 1, I think.
Yes. So next question is why primer is coated before photoresist? So first option is primer coating remove the moisture. Primer coating will clean the wafer. Third is primer coating improve the adhesion of the photoresist with substrate. And the fourth option is primer coating will improve the alignment of mask.
Okay, so this is the C option. You're talking about the
Addition, yes. And this is a very simple question, the temperature of hard bake and soft bake process. So what is the right answer?
Hard bake and soft bake, option C.
Yes, option C. And this is the HEPA filter, R stands for the air filter frequently found in clean room, which is correct full form of the HEPA filter.
Option
High efficiency particulate air, yes. And then the example of a primer is HMDS, AS1818, SU weight or TIMA.
A. No idea. HMDS.
HMDS. And what is the full form of HMDS? Hexamethyl disalinase. And what about the AS1818?
They all are photoresist. The S1818 or SU8. And TIMA is the etching agent. Silicon etching.
Yes.
agent.
What type of photoresist? S1818? Positive or negative?
S1813 is a positive.
S1818
I
also
used
positive photoresist.
SU8 is negative.
Positive.
1818 I think maybe positive.
Yes. So the session is over here. We will meet next Tuesday, 7 to 9 p.m. Okay, you can leave.
Ma'am, we got the mail 2 times. One is for Tuesday and one for Monday. For Monday, no classes happen.
No. Also there is a class now. Another TA is taking the class.
So that link is not work with me. I tried. I wait for some time, but nobody allowed me to join that.
Okay, then I will ask about it. Okay.
Okay. I was thinking that this is the same mail that is
No.
system generated.
Actually, that class is taken by Ashok Kumar, and Monday 7 to 9 p.m. and Tuesday 7 to 9 p.m. I am taking the class, and the link is also different.
And the session is same, something like that.
You can go through the lecture video. Actually, they have uploaded the YouTube now,
Mm-hmm.
so you can
They
check
also
it.
uploaded. Can you share that link with me in this chat? I don't know the channel of Shruti.
Okay, I'm trying to share, but you can here share your mail ID. I can mail you later, na?
Okay.
Actually, I think in the mail the link is given, na?
Video link.
No, not video link, the class link.
I joined that link, but nobody allowing me till I wait half an hour. So I'm thinking I joining before one day. I was thinking this is the same link for your class,
No, no.
but nobody allowing. I was thinking that way, so I just disconnected after half an hour wait.
From 7 to 9 p.m. you have waited.
I never. I tried to Monday, but nobody allowing me that class. So I was thinking this is a system generated mail coming for your class. Because Tuesday I try to always join to your class.
No,
Monday I don't know if the same class happened with other team.
no, actually the TA is different, so the link is also different.
I shared my mail in chat. You can please share that video link so I can go to
Video link means YouTube videos.
YouTube video links. He also maybe uploaded.
Yes, yes. Okay, I will share the video link of him. Okay.
Thank you.
Okay. Thank you.